Okay, guys, I'm here today with Arash and Arash. Yeah? Arash is here with me, and we're just going to go through the making of a circuit board for you guys in year 10 we were on who are producing the DICE project. Just so you know, when you go to, that wasn't the correct one, when you go to new, here, you've got to open this one, circuit with Genie flowchart, okay? And that will allow you to have the flowchart at the bottom. Otherwise, you don't get that if you open the first file there. So here we go. We are on our, look, can you see? I've only got the PCB layout. Opened the wrong one. So I think I've opened another one here, which has got the right one. It's got the flowchart at the bottom. All right, you with me?
Yeah.
He's with me. Brilliant. So we're going to start off by putting, what do you reckon, Arash? What's the first thing that goes in?
The Genie 14.
Genie 14. Now don't bother with these ones because these are, I'm on the wrong one. Should be on the PCB layout. There we go. We're looking for the microcontroller. Arash, can you see it? There we go. Microcontrollers. And in we go. Okay, so we've got the Genie 14 in there. And Arash, you know that top left is pin 1. It goes round until pin 14 over here. So we're the Genie 14. What do we need to make it work? Arash, what do we need?
Power.
We need power, so we need to put in a couple of pads. Now I'm going to put in 2 pads here. If you then select them by pressing the shift key, can you see they've both turned purple? And then I think if you double click them, we can make them a bigger size. I'm making them a bigger size, not 40, just 4, because that's going to be used for our power. And so I've got 2 nice big pads at the top. Now, I also need a download socket, and that is the information socket that I will be, there we go, I will be connecting to my Genie plug and play cable. Give a little bit of room, probably about a Genie's width between the Genie and the download socket. I might just give it a tiny bit more. No, I'm going to come up one. There we go. Right, so what do we know? We know that we need to connect the power to the Genie, don't we? Yes? So let's do that first of all. We're going to do that, but of course what we need to do is we need to turn this on or off. So opposed to going with the high, straight to the high terminal of the Genie, we're going to go to a pad, and then which is going to have an off-board component, which will be a switch, which will let us turn the product on and off. So we're going to have one there, and we're going to have another one there, and that is going to be our 2 terminals. Yeah, I'm pretty happy with that. Okay, so what we've got is we need to connect those 2 together, and we've got our switch up here. When you turn it on, that will then go and power the Genie. So let's join some of these up. I'm going to go down to here. Nice, and you know this is a low.
Yeah.
Arash, you know that, yeah? Okay, so we've done that. So we've got the high and the low, and you can imagine now if we had, and I'll put it in for just argument's sake, I've got a little electrical wire here. You can understand that would work as a switch, yeah? Joining those 2 terminals. So now we've got the high going to the Genie, and we've also got the low going to the Genie. Brilliant. We've also got this little component down here, and this has got the status, which needs to go to pin 13 directly. So let's just connect that. We've also got this one. Now this is a programming pin, or the programming terminal. And so that needs to go through a 22K and a 100K resistor. The 100K pulls it low. The 22K is what they call current limiting resistor and needs to go before pin 2 of the Genie. So, Arash, can you see any resistors there? Resistors, there we go. I would get either the 12 or the 10. I'm going to go for 12. No, I'm not. I'm going to go for 10. That does look a little bit big. And I'm going to put one here. Okay. I'm going to copy and paste another one in. I'm going to spin that round. All right. Pick him back up and put it so it bridges that other. I think I might bring it back one actually. So it bridges that track from the status. And then it's a case of connecting that to. Oh, that's wrong, isn't it? Shouldn't have done that. It's a case of connecting that to here, going up and going to my programming pin of my Genie, and then connecting these 2 together. So now we can see that we've got the current limiting resistor protecting this pin of the Genie. Are you with me, Arash?
Yeah.
We're going to need a pull down on that as well. So that's our pull down. So we know if that's fizzing around, we've got a pull down which always goes low. However, presently we don't have a low. So what are we going to do? Well, this is our low here, isn't it? What I'm going to do is I'm going to take off a low to about here, and then I'm going to take it low on that. So that pin there needs to go low. That is now going low. But also we know our pull down resistor needs to go low, don't we?
Yeah.
Agreed? Yes?
Yes.
So good. So that's our port wired up, our information port, download socket, whatever you want to call it, wired up. We've got our Genie wired up, and we've also got this wired up. Of course, what we don't have presently is any power. Shall I bring my coffee in here? Oh, look, Arash, you wouldn't go and get my coffee, would you? Right, next up, what are we up to? We're going to put a switch in. Brilliant. And what is a switch? Is it an onboard or offboard component? What's a push-to-make switch? An onboard or offboard component?
Off-board.
Genius. Brilliant. It's an offboard. Now, I think people know I don't like D0. It's an analog pin, digital and analog, so I like to go for D1 instead. So what I would suggest you do is you put a couple of pads in, and they will be your two pads that we connect to our switch, our push-to-make switch. Are you with me?
Yep.
Brilliant. And then we're going to come a little bit out, probably come out another 4 or something. Oh, that's wrong. Come out another 4 or something to about here. And then we're going to connect it to the high. Now the high, of course, is over here. All right. So we can now see that we've got a high going to one side of that push-to-make switch, but it's not presently connected to the Genie, is it? However, it is now. Now, one thing we haven't done, what do we need to do if we've got a switch? What do we need? Any ideas? What's this? What's that resistor? What sort of resistor is that?
Pull down.
Very good. We need a pull down, don't we? Just in case we get any of that current fizzing around. So I'm going to put my pull down parallel to my other pull down, so it's nice and neat. And then what I'm going to do is I'm going to connect it to this part of the circuit. I'm going to go out there and I'm going to connect it there. Right, so we've got our pull down. What the pull down doesn't do at present, where doesn't it go?
To the low.
That's right, doesn't go to the low. So let's just go through the middle of the, I'm going to come out a little bit further, middle of that download socket. And so we're nicely all connected. Now, if this is an off-board component, when we pull that off-board component, those wires are going to go taut. When those wires go taut, it's going to be pulling on that soldered joint, isn't it? Yeah?
Yeah.
Yeah. And so to stop that, what we do is we create some through holes, and we put the cable through the hole, and then we bend the rest of the cable over and we solder it. So when you pull on the cable, you're pulling on the through hole, you're not pulling on the soldered joint. Does that make sense?
Yes.
Yes? The way I like to do this, and this isn't convention, but the way I like to do this is I put a couple of pads near, in line with the other pads, and what I do with them is I turn them at wrong, that is, sorry, double click on them, I turn them square. So I know if there is a square pad, I drill it at a different size, but also that square pad relates to the those pads below. Clear?
Yeah.
There is an argument. There is an argument to say that maybe, just in case, we could. I'm just wondering if we could put those anywhere else. No, I think they're okay there. The argument would be, look, what about if you just all of a sudden wanted a new off-board component? So what I'm going to do is I'm going to whack these two in. Can you see that?
Yeah.
And I'm just going to leave it there. Okay? We don't need it, but what happens if all of a sudden we wanted it? you see what I mean? And if we're going to do that, we might as well grab these two. We put them up there. Put them down there. We might even let that do. Okay, and then we can connect, I suppose, cable to that one, another cable to that one. Yeah? Are you with me? Just in case, just in case. Right. We need to do our outputs. Now, what outputs do we have? Can you remember? How many outputs do we have?
4.
4. Do you remember what outputs I don't like? I don't like Q0 because Q0 shares its pin with the status. So I much prefer Q1. Okay, so I want to use 4, Q1, Q2, Q3, and Q4. When you do this, when you're putting pads on, always start in the middle because then you can fan out from either side. I'll show you what I mean by that. Right, let us, I'm going to go for this one. 1. Now I want to use the pad above, so I'm going to go 2 above. Is that right? 1, 2. You see, if I go here, can you see the pads are almost touching?
Yeah.
Yeah? So then I want to go 2 below, and I want to go 2 below that. I hope this is all right. So I'm going to start off by going to the track, going to that second one down, going straight towards it, right click afterwards. I'm then going to put it in at 45 degrees. This is the one I was a bit worried about, but it's absolutely fine, isn't it? So now can you see how we've got 4 outputs? Those outputs are fine, but there's only one terminal. What else do we need?
The LED.
But if you've got, well, this would go up to the LED, but when it comes back down, what does the LED need to contact or be in contact with?
Low.
The low, brilliant. So we need what? We need another terminal. So here we go. Why not? 1, 2, 3, 4. Always when you're doing this, you're always making decisions on what's the neatest way I can do this. Now, why do you think I'm putting the terminals? Oh, apologies for that. Why do you think I'm putting the terminals here and I'm not putting the terminals like up here? Because that's still low. Why do you think I'm putting them there, Arash? What do you reckon the reason for that is?
But you have to connect the terminals together.
It's not to do with connecting it. I mean, this one, for example, I could grab this one and I could put it up here. It's still a low, isn't it?
Yeah.
But why don't I want to do that? Why don't I want to put the low for this particular terminal all the way up there?
It's closer.
Yeah, it's not necessarily. It is closer a little bit, but it's just neater. I now know that all of these terminals relate to one another, and so when I'm debugging a circuit, I don't have to say to you, where's the low for that? Where's the high for that? Because they're grouped in pairs. It's really easy to see. These are going to be the off-board components, aren't they, for the LEDs? Therefore, what do we need?
The pads.
The pads, those 3-hole pads, yeah?
Yeah.
I'm going to put that one just above there, okay? And I'm going to do exactly the same on the other side. I'm going to copy and paste that. I'm going to put that there. So I now know that each one of those pads, those strain holes, refers to that particular pad. Now this is all well and good, but what we haven't done is I haven't put any writing in. So I'm going to start with this one, which is the SW, is a switch. So caps lock on, SW, 1, oh, 1, apologies. And this will come out and it'll be a bit big, won't it? So what I can do is I can right click on there, okay, remember, right click, go to font, and then go to size and go to 6. And it's much smaller, okay? So I'm going to put that one in, good. I'm going to copy and paste that, and I'm going to put it down here, double click, PTM1, okay, copy and paste, double click on that. That's saying PTM1 as well. PTM2. Over we go. Can you remember what Q this is?
1.
Brilliant, Q1. Q2. Q3. Now what you'll find, guys, is that it's rather frustrating because you can't get any of these in the right position. That's because of the lock mechanism that they've got. And so what you can do, and before we do that, I'm just going to put in some other bits and pieces. What resistor was that? Do you remember? It's 100k. I'm going to copy and paste that in because that needs to be 100k, and I'm going to paste it in again, but that needs to be a 22k. Oh, that wasn't any good, was it? Not a 2k. 22k. Right, good. Now, if we go down here, in actual fact, you can't see it because that's the edge of the screen. But there's something with a like a cross grid on it, which says 0.1 inch. If I select that, I can go to snap to grid. I can take it off. So now what I can do is I can move these anywhere. So what I'm going to do is I'm going to put my cues directly in between those different pads that I have. So now that's really neat, isn't it? Yeah?
Yeah.
I'm also going to get this one and I'm going to put it directly under that resistor. This one is going to go directly under that resistor. That's 100k. I'm probably going to spin that actually. I'm not selecting the right thing. All right. Copy and paste. Those PTMs.
Are they 22k?
Pardon?
Why do you have written 22k over there?
22k is going to be over there, isn't it? So I've done that wrong. I've done that wrong as well. There we go. That's that, and that 22k can go. Apologies. Right. We still haven't put the clip back on, so I'm just going to be mindful of that. Okay, PTM1, that's more or less done, isn't it? I think.
Yeah.
So where are we? Okay, let's just see if the whole thing works. So I'm going to leave that piece on. I'm going to get rid of that resistor. What am I going to do next? I'm going to connect some off-board components. So if I scroll down, you can see off-board components. Let's get the power source in. We need to have 3 batteries. Once I've got the power source in, I'm actually going to zoom out and I'm going to move that first. Okay, that's good. I then need to get my 5mm LEDs. I'm happy with this. So I'm going to go 1. And can you see that these have got a flat side? I'm not happy anymore because what I haven't done is gone back onto this and snap to grid. So what we'll find is, actually, I'm going to copy that. What we'll find is that's not exactly snapped. And I don't like it when it isn't exactly snapped. Right. You can see now it's snapping much better. There we go. 4 in a row.
Oh, why is it only 4, not like 6 or?
Because we're just because there's more in the actual product. I'm just testing that the outputs work. Okay, but you're right. I could do, if I was doing this properly, and what I should do later is actually do the dice layout. Okay, but I'm not going to run the dice program. I'm going to run a really simple program. Okay, right. So how do we know this is all joined together? We go to this one, go to the electrical wire, and from the high we go high, from the low we go low. From this one, go there. There we are, all those are going high. Now I'm going to take them all to their respective lows. Okay, they're all low.
But is that on the square, not the circle?
Yeah, so we can't use... Oh, that one there. No, you're right, sorry. Was that the last one I did? All right?
Yeah.
Okay, so we've got our LEDs connected. We now need to get a PTM, which is switches. That's a latching switch. We've got a momentary switch, I think. All right, there's my PTM. Back over electrical wire. All right, anything else? Anything else I need?
Do you need a second PTM?
I'm not going to bother. We don't need one at the moment, but we could use one later if we wanted to do something else, like change the game or an input or something. Right, so let's go down to the program. And the program is really simple. It's just a digital, and it just says, is D1 on? So double click. Is D1 on? If it is on, then I'm going to do outputs are high on 4, 3, 2, and 1. 4, add a wait command. Let's have them on for 2 seconds. Okay. After that period of time, the outputs all go low. Okay, so then they all go off. Once they all go off, we're going to return to the start, and we're going to start the whole program again. So around that goes, around that goes. Hopefully, it's going to work. What do you reckon? Is it going to work or not?
Yes.
What do you reckon?
I think it's going to work.
You think it's going to work? Let's press play and find out. Yay! It should be on for a second, then turn off. 2 seconds, wasn't it? Yeah. There we go. So pretty simple, hey? And that is how you make up your PCB circuit. Good?
Yep.
Nice one. Top marks.